So, Dr. Fraley, I hear that you are the analytical chemist of the chemistry department. What do analytical chemists do, and why are you wearing that shirt?
Okay, analytical chemists are chemists who try to determine what's in a mixture and how much. Now, the reason I'm wearing this Hawaiian shirt is a few years ago, my wife and I went to a destination wedding for her nephew in Hawaii. And we said, goodness, if we're going to pay all the money to go over there, why don't we stay a little bit longer? And we did, and I realized, wait a minute. On the big island of Hawaii, there is a weather observatory that measures carbon dioxide in the air very, very accurately. Turns out in 1958, there was a man by the name of Charles Keeling. And he said, I think I need to know how much carbon dioxide's in the air. I need good numbers. And they didn't have good numbers up until that time. Where can I go? Well, if you're smart, as a chemist, you say, let's go to Hawaii. And he made a weather observatory on the top of Mauna Loa, my goodness, I'm thinking about hurricanes, a volcano about 11,100 feet high. That volcano has not erupted in many years, but it was very clean, pristine air in the middle of the Pacific Ocean. Well, I learned that I could visit that. So I contacted the station master, and he welcomed me to come up. My wife and I had a rental car, and we drove to the top of the mountain. Two things. One, you think Hawaii is lush and green? Well, there was a lot of lava that was black, brown, red, rust-colored, brown, black, and really rough looking. And I repeated those terms because it was mile after mile of nothing but lava. So on top of the mountain, the second thing is 11,000 feet was quite chilly. You think of Hawaii as hot? We had to wear a jacket to keep warm. Now the lab is just about as big as our general chemistry lab here at Georgetown College. That's it. And the station master wasn't even there every day. He would go up about 2 or 3 days a week. Now, let's go back to Charles Keeling. And Dr. Hughes, bring the camera over here. And this is the most famous graph. It's called the Keeling graph, and I think that may be in your book. Starting at about 1958, the level was about 315 parts per million. That's about 31 cents out of $1,000. Right now, as of July, it was 414. Folks, that's an increase of 30%. That's massive. You will not see CO2 go less than 400 parts per million in your lifetime. I don't think. That is scary for your children and grandchildren to think about. Okay, so I did a demonstration with carbon dioxide stretch and bend. This program is called Spartan, and it's an incredibly powerful program that has carbon double bonded to an oxygen and double bonded to another oxygen. Now, this calculation shows that we have asymmetric stretching right there. That is absorbing heat from the sun or radiating from the earth. Let's go over to this weak lower energy right here, and there's that bending motion or scissoring motion right there. Now it turns out, let's go back to this guy. Symmetric stretch, which would be like this, does not have a polarity to it. In other words, both oxygen atoms go out at the same time and come in at the same time. But if they do like this, then there's oxygens on this side of the molecule or oxygens on this side of the molecule. That's what absorbs the energy. That's why we're so worried about climate change with carbon dioxide. It's going up big time. And there's real concern as it goes up, it traps more heat from the sun, producing more warm water, which can make more and more intense hurricanes, drying out the the drought causing problems in California, think about wildfires right now. More problems will occur, but that's just two brief mentions right there. Let's look at the instrument.